Hi, this is Thomas from Apex Game Tools. In this video we'll be looking at the utility AI client. So when you've created your AI, you obviously want to attach it or associate it with a unit so that it can execute and control that unit's behavior. Now there are a few ways to do that. So in this video we'll be covering different options you have. We'll start by looking at the default component-based method. We'll then look at how you can create your own implementation in code where you assign the clients to units in code. And finally we'll be looking at how you can create your own type of utility AI client. So to start off, we'll look at the default with the component-based approach. You simply attach a component to the unit, and then on that component you will be able to select the AIs that should be executed on that unit. That component is already present here. As you can see, we have a utility AI component, and it already has a few AIs attached. Now, if it wasn't already here, you could always go to the menu, and then you could either go to Apex, Quick Starts, AI, and then choose the utility AI client from here. Or you can simply, which is probably even easier, just write util up here and then select it from the list. This will, in addition to adding a utility AI component to the unit, also attach a load balancer by default to the scene if it is not already present. This is because the default utility AI component uses the built-in utility AI client called the load balanced utility AI client that uses the load balancer for execution. So let's have a look at the utility AI component in detail. So it has a list of AIs, that's all it has. You select additional AIs on the plus. This will give you a list of the available AIs that you have created, and then you can simply select from there. You can obviously also remove AIs, you can deactivate them. If you do, this is mainly intended for use during debugging so that you can disable certain AIs. If you have disabled AIs, it's better to remove them than have them disabled if you launch your game. Obviously AIs can be disabled at runtime as well. So the next button here is the view button, so you can open the AI in the editor directly. So if we want to see the scanner tutorial, I can simply click this and it will open up so that we can see what that AI is all about. And then finally we have an option to choose a different AI if we added the wrong one, and instead of removing it and adding a new one, we can simply change the type, and this will just bring up the same window as before to choose another AI. And then we have the settings for the AI. Again, as mentioned, this is the load balanced utility AI client. It has an interval at which it executes. It has a minimum interval and a maximum interval. If these are set to the same, it will, as this is, it will execute every 1 second. If they are different, this one lower than this one, it will execute somewhere in between the lowest and the highest value. Similarly for the delay, this is at the startup of the AI. If you want the AI to start with a slight delay, you can set the delay here and you can have it randomized between a minimum and a maximum value. Now, as explained in previous videos, in order for the AI to operate, it needs a context, and to get that context, it needs a context provider. For the component-based approach, this is also something that you will need to attach to the game object at the same level as the utility AI component. As you can see here, we already have one attached, the example context provider, and this will then provide the context for the AIs. The context provider does not need to be a separate component, you can easily have your unit itself. If it has an object representing the unit, then that object can also be a context provider, which is shown in the survival shooter example. Now, if it wasn't here, if we remove it, you will instead get the option to select the context provider from the utility AI component. So we can just select between the ones available. In this case, we are using the example context, so we're going to choose that, and it will then get added to the game object. So that's the default approach, attaching components to units. Now, if you want to control this yourself, so that instead of having the component-based approach, you will want to associate AIs with your units through code, we'll see how that works now. Now, this example right here actually incorporates both of the two topics that we have remaining, but for now we'll focus on how you instantiate an AI client through code and configure it. So we'll be looking at the included AI client first, and then we'll look at the rest afterwards. So we have an AI handler class that I've created, which will then handle the different clients, that is the different units and the association between a unit and its AI client. So if we look at this line of code down here, which uses the load balance utility AI client, to create one of those, you simply instantiate it, you pass it an ID of an AI, and you pass it the context provider that it should use. So it's very similar to the component-based approach. It needs the same information, but you can just instantiate it through code. Now, the way it references the AI is through what is called the name map. The name map is an automatically generated class which contains an easy reference to the different AIs. So if we dot on the name map, you can see we get the different AIs that are defined in our example project, and we can then choose the one that we want to attach. If you want to attach multiple AI clients, that is multiple AIs to a unit, you need to attach one client per AI, because one client executes one AI. In this example, for simplicity, we have simply attached one client to the unit. Now, if the name map, AI name map does not show up in your code, it may be because you have deselected auto-generating it, in which case you'll have to generate it manually before you can use it. Same goes for if you have it, but it doesn't expose the AI you would expect it to. Again, you will need to regenerate it, and you do that by going to the Tools menu, Apex, AI Settings, and at the bottom you can then click Generate Name Map if it hasn't been set to auto-generate. So for the context provider, in this case I've created a private class that simply gets an instance of a context and just keeps returning that same instance. You can do the same here as I explained that you can do in the component-based model. This can easily be the player object, if that makes sense to you. It can be whatever, as long as it implements the iContext provider interface. So for the rest of the code in here, we'll get back to the other type of client that we see up here. But for the rest of this handler, it simply just registers the client using its game object as a key, and then it registers the client itself in a dictionary. And finally, it then starts the client. So once you create a client, it will have a few methods on it that you can call. You can call start, you can call stop, and you can call pause, and you can call resume. Now in this example we have start and stop implemented. Oops. So we have start in the start method and stop in the stop method. You can also obviously implement the others, pause and resume if you want. And finally we have an execute method, which actually does the execution of the AI, executes the AI, and this you don't call yourself. This is actually called, in this case, by the load balancer in the load balanced utility AI client. So let's have a look at how that works. Before we go back to Unity, we'll just look at the component that exposes the configuration. I've simply created a very simple component that basically calls the handlers start on enable and the handlers stop on disable. So if we switch back to Unity, we have our unit and it has this component on it. The component is only here to have somewhere to call it. Normally, if you have the need to create clients or instantiate clients yourself, it's usually because you have your own update loop or something similar where you want to start and stop clients and probably also execute them. But for this example, we have a component so that it enables us to start and stop automatically. So if we start the scene, which doesn't really contain anything, and look at the AI, we have an action that just debug logs a number to the console, and you can see that happens every second. So we have the AI running. Now there is one thing to note, however. Everything works, but if we try to visualize the AI by selecting our unit, then normally we would expect to be able to see in the editor a visualization of what is happening. But that's not here at the moment. So why is that? The reason is that by default, the way the engine gets a reference to the game object that is currently selected in the hierarchy is through a special method that expects the AI to be found on the default component, the AI utility component. But this is not the case right now. So in order for us to enable visualization, you need to actually tell the AI manager that it needs to get its AI client from a game object in a different way. Now luckily we already have this information because we have our clients registered by a game object, so it's fairly simple. What you need to do is assign another delegate to this method called getAIClient, which is simply a reassignable delegate. It is a function that accepts a game object and a GUID, which represents the AI ID, and then it needs to return the utility AI client instance that is associated with that particular game object. In our case, we simply look up our utility AI client in our dictionary and return its value. So with that in place, we can go back into Unity, allow it to recompile, and then when we start, we will now be able to see our AI visualized. Even though there's not much visualization going on, we can still see that now we actually get our green bars and we get the score and so forth. And finally, we'll have a look at how you can create your own type of utility AI client. As you saw before, we have this other option, the threaded utility AI client. This is simply an example AI client that we'll see implemented now. So let's switch to that. We have it right there. So to implement a different type of utility AI client, you derive a class from utility AI client, and then you implement a number of methods. As you can see, it has a constructor. First of all, it takes the ID of the AI and the context provider as an argument, and then it has these methods that we saw just before. It has pause, resume, on start, and on stop. So in this implementation, we have a utility AI client that uses a separate thread to run. So its implementation is pretty basic, as you can see. It simply registers itself with a thread manager on start and unregisters itself on stop, and pause is simply set through a local variable called isPaused. So everything is actually done by the utility thread manager, which we'll have a look at now. Now it should be noted that this is a mock-up implementation. It is simply to show the principles behind creating something like this. Typically, as mentioned, you will have this in place already. If you have the need for this, you will probably have your own either thread manager or update loop that you want to execute in. But this is then how you can leverage the client in such a setup. So this thread manager simply runs the AI in a separate thread. So it initializes a thread and then it executes. And this, what it does here, is it simply loops through all the clients and then it executes the client using the execute method of the utility AI client. And it does so endlessly without interval. So we'll see that in a second. It's not obviously not optimal. You don't want your AIs to just busy loop and run constantly. That is going to tie up a lot of resources. So again, it is simply a mock-up to show the principles. And we have some register and unregistered methods. They're not really very interesting. They just register clients and unregisters them from a list. So if we go back into Unity, we can, instead of having the load balance client type, we can switch to the threaded mode instead. So now we run in our custom type. And now we'll see this one go berserk down here, as you can see, because it basically just busy loops and runs the AI constantly without pause. So if we were to do this in real life and actually do an implementation like this, you would obviously want to include a scheduler that would schedule the execution of the different clients at some sort of interval. Now finally, with threading, there's one thing you need to know. Since most of Unity's functions are required to be executed on the main thread, only stuff that is non-Unity related will be able to run in such an AI client like this. So that sums it up. That's all for creating your own utility AI client. See you in the next video.